Okay, I've had a bit of a setback with my with fabrication. The company that I had contracted to build the initial pressure hull have called me and said that they are having some financial trouble and they can't do my order. Now, this is really disappointing, obviously, but in a way it's good that they actually told me, because I haven't actually lost any money, rather than them taking my order, me paying the deposit, and then then having problems and not being able to do it. So anyway, unfortunately, I've got to start again with new fabricator, and I've got to suss out if they're any good or not, because I don't know. This company that I used before, I knew them. So anyway, I've got about 3 or 4 quotes coming in. I had a couple already. One of them I've discarded because the company, when I actually spoke to them, because they say they can do it, but then I need to phone and check how they're going to do everything and what the procedures are. And here on this nozzle, I've clearly said chamfer A to be machined there, and they said they were going to flame cut it and grind it, which isn't machining. So I've discarded that one. But then there's a couple of others that are looking pretty reasonable. So I'm pretty sure that this week I'll get the order placed with somebody else. Design is exactly the same. In the meantime, however, one of the guys in the club has asked me a little question about the springs on Jodie B and how I did them. So just because I haven't really got much else to put on, I'll just do a little video of that. Might be useful for him. So one of the guys who's renovating a K-boat, he asked me a question about the hatch. So what size are these? Now, I've just measured these, and these were made by somebody and given to me, and they came from the States, so I suspect it's an imperial measurement. That is about 8.8, and if I look on my chart here, I think it's 1132s. This is it. I've got this Delrin spacer in the middle, which I had to put in because when I closed the hatch, it sort of squashed it all up. So that seemed to keep it neater and tidier. I have got a bit of contact here against this arm. I've noticed this scruffy looking bit of paint there. Look, that's got to be dealt with. Didn't even know that was there. That is contacting there. Quite what happens when it's closed, I'm not sure, because I'm always in it. But what I'm going to do is I'm going to fit the hatch now, and I'm going to get in and close it, because he's asked me to see if the float... Now, there is some float on this. So the original question was that, does it float at this end? And I think there is a tiny bit, but I don't know whether that's the whole hatch lifting. I can't remember how much... well, no. I only put the absolute slightest amount of a slot in. I did it with a file. But having said that, if I dog this down here at the back, and then watch that gap there. See, there's a bit of an air gap here at the front. And as that comes down, you see that is coming down by, I reckon that's come down by a millimetre, just to close that last gap. So it must be dogging, it must be floating in the slot, I think. Not sure if that's of any use. Might be. Oh, so nice to have the springs on. Look at that.
Right, I'm just trying to get clear in my head how these buoyancy calculations go, and if I'm doing it right, if this method's working. So what I thought I'd do is just a quick experiment, and this is literally for me to try and get it clear. So what I've done is I've just made these 2 simple models, 1000 by 1000 by 1000, so 1000 cubic millimeters, which is 1000 liters, or 1 metric ton, 1000 kilograms. So nice and simple. And now Archimedes' principle of buoyancy states that a body immersed or partly immersed in a liquid is buoyed up by a force equal to the volume of the displaced liquid. So in this case, if I dragged this brick underwater, it would displace this amount. So this is the total displacement, and this is the mass. Now we know what they are in this situation. So this weighs 1,000 kilos, and this one, made out of solid steel, I can look at the properties, and it's 7.850 times 10 to the 6. So let's just work that out. 7.850, 6, right, divided by 1,000 is 7,850 kilos. So it weighs an awful lot more than its displaced volume. So it's going to sink like a brick. Pretty obvious. Next thing that I did to check that I'm doing this that the computer is doing this right, or I'm doing it right. Next is I shelled the model. So I've shelled it now. So now let's see what its mass is. And now its mass is 3.863 times 10 to the 5. So let's have a look at that. 3.863. Right, divide that by 1,000. So it's going to weigh now 386.3 kilograms. So that's less than this. So it's going to float. So if that weighs 380, what did I say? 386. To find its waterline, I've done a construction plane. 386 it was, wasn't it? So I've cut it, split the body. So let's have a look at the properties of this now. So 2.28, so it's not quite enough. So let's move it up a bit. Edit that, shuffle it up a tickle. A bit more. Properties, where's it gone? 3.56. Well, we'll say it's there. So that, I think, is now going to be the water line. That's assuming that the water doesn't go in, of course. So I think it's correct, this method. So we'll move on to the proper thing. So the first thing I've done is I need to know my mass. Okay, so I've done the model again. I've been really careful to make sure that everything is weighted as best I know. So batteries, lead, weight of me, where's it gone? Yeah, everything weighs as much as I can get it. So that's now going to give me a total mass. So let's have a look here. My properties of the whole thing. And this is just a little bit of an estimate. Well, quite a lot of an estimate. And the computer has worked it out to be 1197 times 10 to the 6. So let's make a note of that. So that's 1197 kilograms. And that's my total mass. Right, now moving on to the waterline. Now I need to know what the total volume is, and I haven't done it with all the little bits, so this is a little bit of a guess. But what I have done is I've joined everything together. This is so that when I do the properties, I don't have to add them all up. There's these pipes connecting them together. So it's all made out of solid. So this is now like a solid water. So we're looking for, what was it, 1197 kilograms. Now I've probably already done it, maybe, yeah, there. So let's have a look now. If we just hide those, what was this one? Properties of this, 1132, and what did I say? 1197, so yeah, okay, so let's say it's about there. So I think using this method, that is where it's going to float on the surface. So these tanks are definitely not in the right place. What I'm going to do next is I'll do the same thing for underwater.